Welcome to Physical Science, Module 8D, Weather Predictions. Much shorter vocabulary list. We have radar, Doppler radar, the Doppler effect, weather map, isobars, and isotherms. Weather prediction requires measurements of temperature, atmospheric pressure, wind speed and direction, humidity, precipitation, cloud cover, cloud type, and upper atmospheric conditions, all of which we've learned about in the last two modules. Our first definition, radar. Radar comes from radio detection and ranging. Radar provides meteorologists with data regarding cloud cover and types of clouds forming in the atmosphere. Radar units have transmitters that emit radio waves at a rate of several hundred per second. When radio waves contact objects, the waves bounce off of the objects and hit back to the radar unit. A receiver unit in the radar then records when the bounce signals return. The time taken for the waves to travel back and forth tells us how far away the object is. Weather radar can determine whether a cloud contains ice crystals, which would be a cold cloud, or water droplets, which would be a warm cloud. When the radar unit is turned in a 360-degree direction, it can provide information on the entire surrounding area. Doppler radar. Doppler is a well-known tool for both weather and law enforcement. Doppler radar uses the Doppler effect. The Doppler effect analyzes specific kinds of differences, wavelengths, between outgoing and incoming waves. Doppler radar analyzes the speed of the objects, so it can analyze winds, air masses, and so forth that we're observing. This is how police officers also use Doppler to see if you're speeding. Meteorology made its greatest advances when satellites were deployed for weather-related measurements. The first successful satellite, TIROS-1, was launched in 1960. Now many weather satellites circle Earth. The satellites give an accurate global picture of weather fronts and patterns daily. Because weather satellites take continuous measurements worldwide, they've provided the best evidence to date that global warming is not happening. The chart, figure 8.9 on page 195 of your text, shows average global temperature changes since 1979. This is based on satellite data. The charts we covered in Module 2 showed data from land-based instruments and therefore were not as accurate. Let's take a look at that chart. This chart shows us that variations are minor. To find out how to read a chart, the first thing you want to look at is the measurements they're using to actually record data. There's a very small difference between 0.6 and 0.4. So the variations that it will show will be very slight variations. Up until 2001, there were more colder temperatures than warmer ones. So the red shows the warmer temperatures, and up until 2001, the blue or purple showed cooler temperatures, and they essentially balanced each other out. It's only been recently that temperatures between cold and warm have not evened out. The satellite network augments land-based data. The data is compiled in a weather map, and here's a sample of a weather map from our text. The thin black lines on the map are isobars. So that's these lines that you see going around the weather map. Isobars represent regions of equal atmospheric pressure. So all the pressure in this region will be the same. If you travel on a single isobar, the pressure will be stable. So I could go from down here in Mexico along this isobar and experience the same pressure the whole way. The large H on the map tells us that the isobar represents high pressure. If you see an L on the map, it's low pressure. Because winds blow from high to low, isobars help indicate increasing or decreasing pressure. These colored lines you see are weather fronts. The arrows show you what direction they're pointing. So this front here, this low, is actually moving southeast. This front is moving directly east. This front is moving northwest. And this front is moving east also. Oh, and it's also moving west, so it's a stable front. The fronts on the map provide a great deal of weather information. Predictions about warm or cold fronts and their directions can be made. Some weather maps plot isotherms also in addition to isobars. Isotherms are lines that represent constant temperature. All weather-related data is plotted on computers, and mathematical models predict the weather. What your meteorologist does is he looks at those models, and I've heard them say on the news that they look at up to 10 models every hour, and then they average them out basically to predict the weather. So it's not just one model that they use, it's many that they average. Still, that doesn't give us totally accurate weather predictions, but they're much better than they used to be. So that's it for this video. If you need any help, be sure to contact me. Have a blessed day.